Welcome to Winning Edge. Today we will discuss general principles and processes of isolation of elements. We know our modern day civilization is based on steel and other alloys. These metals and alloys have laid the foundation of industrial revolution, mining industries, purification of metals, laying down railway tracks, manufacturing of cars, to the manufacturing of advanced aeroplanes, and much more. All industrial activities, one or the other way, associated with these metal purification and alloy manufacturing activities. So, let's discuss the principles used for purifying the elements. First, isolation of element. Out of many minerals in which a metal or element may be found, only few are viable to be used as a source of that metal. Such minerals are known as ores, or we can say ore is a mineral which is viable for purification. Viable means economical viability. Most of the elements in Earth's crust exist as minerals and combined form, except few elements like carbon, sulfur, gold, and noble gases that occur in free state. Contaminants or undesired materials present in ore are known as gangue. These extractions and isolations of metal from ores involve steps. First is concentration of the ore. We having an ore that contains a lot of impurities. We need to get rid of those impurities for its purification. Like first is mining. We mine it. After mining, we shift it and crush it. This is a crusher, so that we can reduce into a powder form. Thing is, in a powder, because of its small particle size, having a large surface area, so it's crushing and powder making process, mining, and then powder making. After the concentrated ore, we have to get a metal from it. It's shifted into a certain furnace sort of thing, where, like in case of iron ore, we feed it with coke, lime, and then finally we get a purified metal at the bottom. The molten iron is collected from the bottom, and slag is ejected, which comes up on the top of it. That's how furnace work. We have to purify the metals by removing the gangue and undesired impurities from it. First, occurrence of metals. Earth's crust is composed of metals and non-metals in different abundances. Among metals, aluminium is the most abundant metal in Earth crust. This is our Earth. And maybe you are surprised, the most abundant element on Earth is oxygen in pure or combined form. This is the Earth structure. Outermost layer known as crust. Mantle is a semi-molten part, and then Earth's core, which is made of nickel and iron. 46.6% oxygen, 27.7% silicon. Rest makes up. And third most abundant element on Earth is 8.1% aluminum in Earth's crust. There are numerous ores occur for given element. The selection of ore for the mineral extraction depends on economic of production and environmental considerations. More environment polluting ores sometimes will not be chosen because of strict environmental regulations. Bauxite is chosen for aluminum. Iron, usually the oxide of which are abundant and do not produce polluting gases, like sulfur dioxide is produced from iron pyrite, FeS2. That's it, produce sulfur dioxide. Concentrating ores is a method of eliminating gangue particles or the other impurities. It is also known as ore dressing or ore benefaction. Maybe these are other names. Ore benefaction, ore dressing, and ore concentration are same. It is basically removal of gangue from it. First is hydraulic separation. It is based on the difference in the gravities of ore and the gangue particles. What does it mean, gravities of the ores? It means based on their densities. Hydraulic separation is based on the densities, because if ore is crushed and cleaned with water, flowing water, the lighter gangue particles with low density, they will washed away and heavy ores will settle down. Magnetic separation is based on the magnetic properties of the ore. For example, iron ores which are having magnetic properties while these gangues don't. Froth Flotation. This is based on the principle that suspended powdered ore in water, in which ore having a high propensity to form froth with the suitable agents, then gangue, and this froth can be separated. Next is our leaching. It is used for ore soluble in some suitable solvents, while gangue particles do not. Silver and gold ores are mined by leaching with dilute solution of sodium cyanide or potassium cyanide, and aluminium is leached from bauxite using sodium hydroxide solution. These few methods we saw used for concentrating the ores. It's not a purification, it's just a concentration for removal of the gangue. First, hydraulic separation, concentrating technique. It's on the different of densities, and further in densities it affects the having different gravitational effect. It's a wash plant, in which top of that we use running water to wash away these lighter impurities, and powder ore is fed from the top. See there, and lighter gangue particles will be washed away with the water, and these heavy metals will be settled down in these trenches in the wash plant. Next is magnetic separation. It is based on the magnetic properties of ore and gangue. Ore, like iron ores, having the magnetic properties. So this is a magnetized drum. This side is magnetized, and this ore, iron containing ore, will come here, and gangue particle will settle here. We are pouring over here, magnetic drums rotating, separator, and ore we get here, gangue on the other side. Next is Froth Flotation. Suspension of powder ore in water, which make froth, and is converted froth using the collectors and stabilizers, converted again into desired ore or element which is concentrated. Like first we stir it uniformly by mixing with a certain oil or form making agent. With the stirring there is a uniformity. Then we bubble air through it so that enough froth is made. Then this froth will comes up and collected in froth collecting pit here. This froth comes up here. From there it is concentrated and gangues will settle down. Leaching is used if the ore is soluble in some particular suitable solvent, while gangues do not. Silver and gold metal is leached with the dilute sodium and potassium cyanides, and aluminium is leached using sodium hydroxide from bauxite. Now in this process, so bauxite leaching, sodium hydroxide at 473 to 523 Kelvin, which is roughly 2 to 200 degrees Celsius to 250 degrees Celsius at high pressure, 35 bar, and we are getting sodium aluminum hydroxide. This is soluble. Silica 2 makes a sodium silicate. Aluminate in solution is neutralized by passing CO2 gas. This after the solution, alumina is solubilized in sodium hydroxide. We bubble CO2 in it. And next stage, what happens? It is converted into alumina again, which is pure compared to, and sodium bicarbonate is also here. This alumina is pure compared to earlier crude alumina, which can be used for further refining. We heat it up to get an unhydrated alumina at a high temperature, roughly 1200 degrees Celsius. Leaching. Now leached metal from the ore is in solution and gangue settles down. This clear solution from which we can get our metal.